Hello everyone. Okay, today we're going to talk about compilers. Why we need a compiler. First of all, what is a compiler and everything. Okay, so if you have listened to the first one, which is about programming languages, why we need a programming language, and it's good. If not, it's not bad actually. So we will do a small recap, like what we discussed in the first unit, like what is a programming language, and we discussed about smart devices, how it becomes smart by by putting some smart gadgets or smart electronic chips into that devices. It makes them a dead device or a monotonous devices into a smart device. That's what we discussed about. So to make it smart, we need to program these processors or the controllers, which will do the routine of work they do in a different way, right? That's what we discussed. So the programming languages are a high level abstract for these machine language or assembly language, right? It's kind of that. So this is a picture which is clearly shows the flow of the execution, programming language to assembly language, then to machine language. The high level languages are nothing but the programming languages. Okay, so how it gets converted from high level language into assembly language using compiler do that. How assembly language converts into a machine language using assembler, we are not going to discuss much about it. We're going to discuss only about compiler. Okay, so what is a compiler? As we said, now it converts your high level programming language into an assembly language, which could be fed into the assembler, and which will convert that assembly language into a machine code. The machine code is the one which processor can understand, or processor will understand only the machine code. Okay, I will pick a small kind of a example, or I don't know, it's a story, it's not a story, small thing, just you can pick it up from here. Maybe the guys who knows about it, it might looks funny, but for people who are just new to this programming world, can connect these kind of dots into something else. Okay, it might give you some idea about it. So say for example, you are going to a shop, and you're going to a shop with a list of items to buy, which is written in English. It's been given to you by someone, and it's written in English, and you know English, and also assume like you know French, and you're going to a shop, and the shopkeeper knows only Arabic, and he can't even read English. So nothing could be done here, because you know only English and French, and that guy knows only Arabic. And luckily you are getting another guy, and he knows French and Arabic. So what you can do here, you can convert those English, written in English, into an French, and you can give it to that guy, and that guy will convert that French list into an Arabic, and he will give it to the shopkeeper, and shopkeeper will give you whatever the items that you required, or it's been whatever been mentioned in that list, right? So more or less that's what happens here, right? Compiler only knows the machine code. It won't know anything other than that. So, and the compiler, sorry, the processor knows only the machine code, and the compiler is going to help us to achieve that, right? So the compiler, I would say, like it's is the one which converts your uh, French script into that Arabic script, right? Or I would say that is assembler. Maybe the one which converts from English to French is the kind of compiler. Okay, but this story is not an exact match, or a story as a narrative is not an exact match to what has been compiler, and why we need a programming language, and why we are not using these assembly languages straight away, right? It's not an exact match, because in the narrative that we discussed, I can learn an Arabic, or the person who goes to the shop can learn an Arabic, and he can do that. it's not a big deal. But here, that's not the only case. Just for an easy to grasp it, you can take that. But the thing is, right, even if you know assembly language, even if you know machine code, you cannot use that to program such a such a very big applications. Like if you want to develop something like WhatsApp, or if you want to develop something like Instagram or Facebook, then you cannot sit and write assembly codes, you cannot sit and write machine codes, and you will understand why uh, when we go down and learn much more. But at the moment, it's like if I want to write say for example, here it's very simple. In this picture, if you see, like, it's something has been defined like add xy, so it returns sum of x and y, right? So that two lines of code will at least require 10 lines of code in assembly language. So I'm saying this is very simple operation. For that itself, it requires that. So in programming world, even a very complex operations can be written in 2 or 3 lines. So those 2 or 3 lines might end up in some 100 200 lines of assembly code. So that's the reason we are not using the assembly code or a machine code. We are writing using a programming language. Okay, so the compiler is the one which will translate. It's not exactly translating, just for for understanding, I'm just using that word. But the compiler, what it would do is, right, like whatever that we written using the programming language will be given to the compiler. So say for example, when you given some paper written in some language and someone translates, what are the things they check? They will check whether the words written, say for example, if they're converting from English to Arabic, then they will check whatever the words written in English, is that a correct word. If the word is not correct, or if they don't know that there is no such a word in English, or they won't know that word in English, then they're going to raise it as an error. There is no such a word, right? If it is grammatically completely wrong, then they're going to raise it as an error. No, this sentence is making no sense, so I cannot translate that to Arabic, right? So similarly, compiler will also do the same thing. When you write a programming using a programming language, and when you feed that into a compiler, compiler will check whether every word written in that is a valid, right? Then it will check whether the syntaxes which needed to be followed. For example, if you look at this diagram, there is a colon, there is a semicolon, there is a comma between x and y, and there is a space between def and add, and there is a indent, or there is a tab in the before the return, right? So a lot of things involved. So those kind of things are syntaxes, like how we have to follow while we write you know a code in the program using a programming language. So a lot of things are involved. So compiler will verify all those things, whether everything has been followed properly. if if something is wrong, then it will raise it as an error, and that we will fix it. Then we will run it and we'll compile again. So if everything is written properly, then it will compile successfully into an assembly language. Then assembly language will take it into a machine code, right? So this is compiler. In simple terms, we will be writing using a high level language, which is more or less closer to English, and we will be following some rules. We will be write the codes accordingly using that language, and the compiler will check for those rules and the keywords, everything. If they are all proper, and they will convert that into an assembly language code, and that from there it will be converted to a machine code. So the compiler is one which converts the programming language into a assembly language, and assembly language will be converted to machine code. So this is what all about compiler. Now might be I given dots, or I might even given some more informations. Just try to understand or take it whatever that you want, and be prepared for the next one, that we will be discussing about Now we will get into the code, like simple codes, like so that you can connect what compiler do with that code, and what that code will convert it to, and everything that we can get into in the next unit. Okay, thank you, thank you everyone.